Okay, so this is topic 16, applications of quadratic functions. So all this is using the properties that we learned with quadratic functions, and we're putting them into a word problem. So looking at number 1, says an object is launched directly upward at 19.6 meters per second from a 58.8 meter tall platform. The function for the object's distance from the ground d at time t seconds after launch is the formula d of t is equal to negative 4.9 t squared plus 19.6 t plus 58.8, where d is in meters. It's asking us, when does the object strike the ground? Okay, so what we should do first is we should draw this diagram out. Okay, so it says an object is launched directly upward from a platform that is 58.8 meters tall. So we have our platform, and this is 58.8 meters. Okay. Our object is being thrown up, and then it falls down. So that's the path of our object. And then we can say the ground is how many meters?
To the ground?
The ground. It would be 0. Okay. So it is dropped from a height of 58.8. Once it reaches the ground, it is at 0 meters. Okay. So if it's asking us when does the object touch the ground, then we're going to have to I just realized why I mixed up the things, because I was supposed to teach quadratic formula first. That's okay. I'll just teach it here and we'll go over it again. So when an object hits the ground, that means the distance is 0. So for d of t, we're going to be plugging in 0. So we have negative 4.9 t squared plus 19.6 t plus 58.8. Okay. Each of these components contains our A, B, and C values. So this is A, B, and C. Okay. This is important because when we solve a quadratic function, when it is equal to 0, oh, great. There we go. When it is equal to 0, then that means we have to use the quadratic formula. So let me go ahead and write the quadratic formula. So the quadratic formula, since we're dealing with the variable t, is going to be t is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay. Again, this quadratic formula is going to help us find the zeros of a quadratic function. Okay. And again, the reason they are called zeros, because if we look at the application and we look at when the object hits the ground, it hits the ground at 0. So if we're imagining this as the x and y axis, it's when it will hit the x-axis. Okay, so the only hard part about this is you have to know the formula. Once you know the formula, you can plug in your A, B, and C values and then plug it all into your calculator. Okay, so I'm going to go ahead and plug in my values. I don't know t, so I have t equals negative b, means I take my b value and I do the opposite. So my b value is 19.6, so I'm going to write negative 19.6. Plus or minus the square root of b squared. So again, b is 19.6, and then I'm going to square it. Minus 4ac, so minus 4. And our a value is negative 4.9. And our c value is 58 58.8. Okay. Then the last part of our formula is everything is divided by 2a. So 2 times our a value, which is negative 4.9. So all I did here was plug in my a, b, and c values. Okay. From here, I'm just going to start simplifying by plugging things into my calculator. So the easiest way here is to first plug in this part into your calculator, everything that's under the square root. So you would plug in, using the parentheses, 19.6 squared minus 4 times 4.9, negative 4.9 times 58.8, with those parentheses. Okay. When you do that, you should get, under the square root, 1,536.64. So remember to include all your parentheses. So parentheses around the 19.6 and square it. Okay. The minus 4, and then in parentheses, that negative 4.9, parentheses again, 58.8.
I'm doing that and I'm getting 34.23.
34.23. Let me try. Is anyone else having that same problem?
Nobody else?
Did you square the first number? Yeah, because I'm getting the same thing. Just make sure your parentheses are correct and we're squaring that first number. Okay. And then on the bottom, if we do 2 times negative 4.9, we get negative 9.8. Okay. And then we would take the 2 parts, because see how it says negative 19.6 plus or minus? That means we have 2 possible answers. I made this diagram way too big. I'm going to put this off to the side. Okay, so that means we have an answer where t is equal to negative 19.6 plus that square root divided by negative 9.8. And then we have an answer where t is equal to negative 19.6 minus that square root. So once you separate them into plus and minus, you can again plug into your calculator. Just make sure that this whole top portion here is in parentheses when you plug that in, because this whole thing is being divided by that negative 9.8. Okay. Anyone get answers for this? Our 2 t values?
Why'd you move that negative 9.8 up, man?
Why did I move it up?
Oh,
What do you mean?
No, nothing.
Okay. Yeah, this part right here is, is separate.
Sorry.
Okay. So when plugging these into the calculator, you should have got t is equal to negative 2 and t is equal to 6. Okay, 2 possible answers. However, in this problem, what does t represent? Time. So which one of these is the only correct answer we can have? 6, because can we have negative time? No, so that means that it will take how long for this object to hit the ground? 6 seconds. So that's what we would write. Running out of room. The object takes 6 seconds to hit ground. And again, we'll be getting more practice on the quadratic formula on the next notes. So we'll use this as an introduction, and then we'll get more practice on Wednesday. Okay, so that answers the question for 1, because it was just asking us, when does the object strike the ground? So anytime you see this in a quadratic application, you're always plugging in 0 for the formula, labeling your A, B, and C, and then using the quadratic formula, okay, for these type of problems. On problem number 2, it's asking us a different question. So it says a ball is thrown into the air. The height of the ball above the ground is represented by the function h of t is equal to negative 16t squared plus 8t, where h is the height in feet and t is in seconds. It says, when will the ball reach its maximum height? So again, we draw our diagram. Okay, so this is representing height, and this is representing the ground. Okay. So if a ball is thrown from the ground, it's going to go up, and then it's eventually going to hit the ground again. Okay. Our question is, when will the ball reach its maximum height? So the maximum height on a parabola is called what?
Vertex.
The vertex. So that means we're going to use that vertex formula. So vertex maximum. Okay. And remember that the vertex formula is that negative b over 2a, and then we plug in whatever that negative b over 2a is into the function. Okay. So we have the function h of t is equal to negative 16t squared plus 8t. We need to label our a, b, and c. However, notice we don't have what value? C. So we only have A and B, which works because that's the only ones we need for the formula. Okay, so plugging into our formula, we have that our x value equal to that negative b over 2a is going to be equal to negative b. So what value am I plugging in? Negative 8. And then 2 times a, what's a? Negative 16. So that means I have negative 8 divided by negative 32, which gives me what fraction? 1/4. And how would I turn that fraction into a decimal? 0.25. Okay. So I'm going to take that 0.25 or that 1/4, whichever you prefer, and plug it back into the h of t function. So now I have my y value, so this part here, is going to be equal to when I plug in that function. So f of 0. Well, not f, our function's in h. Oh my gosh. Sorry. Okay. So h of 0.25. So that means I have negative 16 times 0.25 squared plus 8 times 0.25. Okay. So I would just plug that into my calculator exactly like this, and you'll get an answer. And the answer you should have got is 1. Yep, definitely use this time to practice using your calculator. Make sure you're getting the same things. So that means our vertex should be 1. Because if you simplify by hand, this first section gives you -1, and this second section gives you 2. So -1 plus 2 is +1. So you should have got the vertex of 0.25, 1. Remember that vertex represents seconds and feet. So we have to go back up to our question. It says, when will the ball reach its maximum height? So it's asking for time. So after how many seconds will it reach its maximum height?
0.25?
Yep. So we would write that the ball reaches max height at 0.25 seconds. Okay. And what is the max height of the ball? 1 foot. Good. So that's how you would find that question if they ask you what is the max height versus when will it reach the max height. Okay. Okay, then number 3 has a lot of different questions we're going to be answering. Okay. Number 3 says the graph models the function h in feet of a rocket t seconds after it launches. So it's telling us what our variables are here. The path of the rocket is given by the function h of t is equal to -16t squared plus 128t. Okay. Notice that all our quadratic functions so far all have a -a value. That's because when we're talking about applications of quadratic functions, most likely we're talking about something that is launched, goes up, and then goes down, meaning that the a value has to be negative for that parabola to be upside down. Okay, just keep that in mind. Okay. So here we're first drawing our diagram. So we have our height and our seconds. Okay. This is saying that a model rocket is shot up, and then what goes up must come down, so it's that upside down parabola. So the first question is, how long is the rocket in the air? How long is the rocket in the air? So in order to solve that, we have to calculate this distance here once it reaches the ground level. And we said the ground level is what? 0. So I'm going to be plugging in 0 in for the h value. So I'm going to have our equation set equal to 0. Okay. So we have -16t squared plus 128t equals 0. Anytime we set a quadratic equation equal to 0, we always use the quadratic formula. Okay? When set to 0, always use quadratic formula. Okay. And remember, our quadratic formula is t equals, because t is our variable here, -b plus or minus the square root of b squared minus 4ac all over 2a. Okay. So we need to plug in our a, b, and c values into this function here. So we have our a value of -16, our b value of 128, and what number are we plugging in for c? 0, because it's not there, it doesn't exist. Okay, so plugging that in, I have t is equal to -b, so -128, plus or minus the square root of b squared, so 128 squared. And what's going to happen to this minus 4AC?
It's going to be 0.
Good, it's going to be 0 because our C value is 0. So that means if we did negative 4 times A times C, we should get 0. Okay? So I'm not going to write that part because this part is just going to be minus 0. Okay? And then I'm going to write that all over to A, so 2 times negative 16. Okay? So first, what I would do in my calculator is I would do 128 squared and then take the square root of that. Or you could remember that a square and a square root cancel each other. So that means you will get 128 even if you square it and then take the square root. So we have t is equal to negative 128 plus 128, or sorry, plus or minus, all divided by negative 32, because I multiplied that 2 times negative 16. Okay. So that means we have two possible answers here. We have when t is equal to negative 128 plus 128 divided by negative 32, and t is equal to negative 128 minus 128 divided by negative 32. That first time where we have negative 128 plus positive 128 is going to give us what value? 0. Okay. And then plugging in the second part into your calculator, what value do you get? It's going to be a whole number. Should have got 8. 8. Okay. Remember, if you're not getting that number, make sure you put this top part in parentheses before you divide. Okay. So, based on our question saying how long is the rocket in the air, which time makes the most sense? 0 seconds or 8 seconds?
8 seconds.
8 seconds. Okay, so for this part, we would say rocket in the air, 8 seconds. Okay. Now it's asking, what is the maximum height of the rocket? So if we're looking at this graph, maximum height is always going to be the what? The vertex. Okay. And we find the vertex using the vertex formula. So I'm going to zoom in a bit here. Okay. So remember the vertex formula is that negative b over 2a, and then we plug in whatever value we get into the function. Okay. So we have our x value of negative b over 2a is equal to, what's going to be negative b? Negative 128, and what is our a value? So 2 times negative 16. So if we plug that into our calculator, you should get 4. Go ahead and test that out. Once we find that x value of 4, what are we going to do? Plug it in. So we do our y value. So y is equal to our function plugging in 4. Okay, so that's negative 16 times 4 squared plus 128 times 4. Plugging that into your calculator, what do you get? Perfect, 256. Which means that we have the vertex of x comma y, so 4 comma 256. But it says, what is the maximum height? Good, so the maximum height is that y value, because y is height, and x is seconds. So that means our maximum height is 256 feet. Okay, and we reach our maximum height at how many seconds? 4 seconds. So it takes 4 seconds to reach the height of 256. Okay. Next part says, what is the height of the rocket 2 seconds after it's launched? What do you think we're going to do with that 2? Correct. Plug it into our function. So instead of plugging in 4, we are now plugging in 2. Okay, so we have our function, negative 16t squared plus 128t. Instead of t, I'm going to plug in 2. Negative 16 times 2 squared plus 128 times 2. Plug that into your calculator and you get You said 194? 192? Trust you here because I don't have my answers pulled up. Okay, everyone else get 192? Okay, and that's going to be 192 what? Feet. So we would write our sentence that says, at 2 seconds, the rocket reaches 192 feet. So at 2 seconds, rocket is at 192 feet. Again, these are applications, so every answer has to be written in a sentence. That's why we're writing a sentence for each one. Okay. Next question says, is the rocket going up or down 2 seconds after it is launched? It's going up. How do we know? Good, because if we were to look at our graph again, we said that the maximum height right here is 256 at 4 seconds. When we did 2 seconds, we said that our height was only at 192, meaning that our rocket has not reached our highest point yet, so it's still going up. Okay, so we would say the rocket is going up. Okay. Next question says, what is the height of the rocket 6 seconds after it is launched? What are we going to do with that 6?
Plug it in.
Plug it into our function. Okay, so just to remember, our function is h of t is equal to negative 16t squared plus 128t. And we're going to be plugging in 6 now. So h of 6 is equal to negative 16 6 squared plus 128 times 6. Okay, go ahead and plug that into your calculator and tell me what you get.
192 again.
192. Yeah. Okay.
Oh, true.
Okay, so that tells us that at 6 seconds, the rocket is at 192 feet. How is that possible? Because at 2 seconds, we also said it's at 192 feet.
Now it's going down.
Now it's going down. So it went up, it reached that point of 192, and then when it's going back down, it's also going to reach that height of 192. And that takes us into our next question. Is the rocket going up or down? So again, if you're not sure, we draw our diagram. We know that our vertex, which was at 256 at 4 seconds, and we know at 2 seconds it was at 192. And so at 6 seconds it's also at 192. But this time it is going down. Okay. So the rocket is going down. Okay, and if you're ever not sure, draw that diagram. Okay. Okay, now it's giving us a problem to estimate because we don't know exactly what this is. So it says, when is the rocket 112 feet high? Okay, 112 feet high. So that means our equation is going to be equal to 112 because h is the height. So we have 112 is equal to negative 16t squared plus 128t. Remember, we can only solve quadratic equations if it's equal to what? 0. So what are we doing with that 112? Good, subtracting it over, and that's going to become our new what? Our new c value. Because when we subtract it over, we now have our a, b, and c. Which tells us we're going to use what formula? The quadratic formula. So I'm going to rewrite here the formula. So t is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So into our formula, we're going to be plugging in our a, b, and c values. So I have t is equal to negative b, which is going to be what? Negative 128 plus or minus the square root of b squared, so 128 squared, minus 4 times a. I'm running out of room here, so I'm going to write it down here. So times a, negative 16, times c, negative 112. All divided by 2 times a, which is 2 times negative 16. Okay. So remember, what you're simplifying first is everything under that square root. So you're going to do parentheses, 128 squared, and then you're going to do minus, and then all this should also be in parentheses because you're subtracting that entire thing. Minus 4 times negative 16 times negative 12. And when you do that, you should have got, so t is equal to negative 128 plus or minus the square root of
96.
I got 9,216.
What am I doing wrong?
I got 96.
Really?
I got 9,000.
Oh, did you guys get 96 after you took the square root?
Yeah.
Okay, I haven't taken the square root yet. Is that why?
Oh, maybe.
Yeah.
Oh, well, I'm putting everything under the square root already.
That's why. That's why you were getting different answers, which is
Oh.
fine. I'm just doing it step by step.
Got it.
Okay, so I only did what was under the square root. I didn't do the square root yet. So that 96 is correct.
Okay, good.
Okay. So that means I have two parts of my answer. I have t is equal to negative 128 plus, and we said the square root of 9216 is 96 over negative 32. And then I have t is equal to negative 128 minus 96 over negative 32. Okay. Okay, so that means I get two t values, and what are those t values? What were the values? 1 and 7. I got different numbers. Anyone else get different numbers? Or did everyone get the same? Maybe I messed up in this one.
I got 1 and 7.
Okay, that's my bad. I got it messed up then. Okay, so 1 and 7. Okay. And remember, our question was, when is the rocket going to reach 112 feet? So are one of these answers correct, or both of these answers correct? Both are correct. Why?
Because it's up and down.
Good. So that means it's going to reach 112 feet at 1 second going up, and then reach 112 feet at 7 seconds going down. So we would write that out. So we would say it will reach 112 feet at both 1 and 7 seconds.
No, this says estimate.
Well, the reason it said estimate is because we could have got a decimal answer. Okay, but for this one we got whole answers of 1 and 7. Okay. Next question says, do you think the rocket is traveling faster from 1 to 2 seconds or from 3 to 4 seconds? Explain your answer. Why would we say 0 to 1? Good. So we would say that when the rocket travels faster from 0 to 1 second, since the slope is steeper. Because if we look at our slopes on the graph, let's say that this section right here is from 0 to 1. And this section right here is from 3 to 4, because remember we reached 4 at the vertex. Notice that this first slope is almost a complete vertical line going up. So this is a steeper slope, meaning that the rocket was traveling faster. And then in the 3 to 4 seconds, our slope is starting to curve, meaning it's not as steep. It has to slow down a little bit before it makes that turn. So this part would be slower. Okay, so we would say rocket is faster, 0 to 1 seconds, since the slope is steeper. Any questions on that one? And then last part of this question is asking us to produce a reasonable domain and range. Okay? So we know that domain is what values?
All real numbers.
Well, we're dealing with a word problem now.
0 to 8 seconds. No? When 0 come at, 8 come at 0.
Okay, so you're correct, but I just want to know what variable is domain?
Oh, X.
X. And in this case, we know X is what? Seconds or height?
Seconds.
Seconds. So we established through all this math that for the starting point of this graph, where it starts on the ground, is at 0 seconds. And then how many seconds did we say it was going to take to hit the ground again? 8 seconds. That's why it's 0 to 8. Okay, so we are dealing with an application, meaning we have strict start and end points. Okay? So range, we know is y's, and we know y represents what? Height. What was the starting height of the rocket? 0, right? Because we start at the ground. And what was the maximum height? 256. So that means the domain for this problem was from 0 to 8 seconds. And the range for this problem was 0 to 256 feet. So it's always going to be where it starts and then ends. Starts, ends. Okay, so for an application, we can't automatically say the domain is all real numbers. Only when we're talking theoretical, those other examples. Okay, any questions on number 3? You'll have one problem like this on the upcoming test. That just means the test won't be so long. Okay. Okay, so on number 4, it gives us a diagram. Okay. Gives us a diagram. And this diagram is talking about the lower end delay of the epidemic peak. Okay. So we're talking about the number of cases versus the time since the first case. So that means this axis right here is the range, the y's. And again, this is the number of cases. And then this axis right here at the bottom is our x's, which is our domain. And this is representing time. Okay. The first question says, estimate the y-intercept of both graphs. So we're looking at the graph that has that tall graph, and then we're looking at that short graph. So we know that the y-intercept is where it crosses where? The y-axis. So looking at the y-axis and looking at both graphs, it looks like that both graphs start at the same position, which is 0. So we would say both y-intercepts are 0. And why can we say that they're 0? What is this graph representing? Good, 0 time, and it's at that origin, so it's also 0 cases. So this is the very beginning of the epidemic. So since there are not any cases before the epidemic. Okay. And what are both of our graphs representing? Why are there 2 graphs here? So just these labels right here. Good. So this one says uncontrolled transmission of the disease. And this bottom one is controlled transmission of the disease. So, and then it says here, control measures the slow spread of the disease and reduce of hospital burdens. Okay? So that's what the 2 graphs are on this thing. So it says interpret and compare the vertex of the graph on the left to the vertex of the graph on the right. So let's first look at this vertex here. Okay. What is that vertex representing on the graph? So don't think numbers. We're just reading this graph to see what that vertex represents.
It's the peak of the uncontrolled spread.
Good. It is the peak of the uncontrolled spread. And we could say, let's say that. Let's do that first. So the graph on the left, the vertex shows the peak, or we could write maximum of the uncontrolled transmission. Okay. So comparing that peak to the peak of the second graph, what could we say about these two graphs?
The uncontrolled was a lot worse. It was a lot more.
Good, there was a lot more cases compared to, look at it compared to time. So there was a lot more cases
In a shorter amount of time.
in a shorter amount of time versus the second graph that had a lesser amount of cases over a longer amount of time. So we would write that to continue our answer. Yeah, this type of problem, we're not doing math. We're just interpreting a graph. Okay, and this is how we would use, or how you guys would use the quadratic functions in a real life example. You're not doing the math, you're using all that information to interpret information. Okay, so we could say that the left had more cases in a shorter period than the right. Okay. Now it's saying interpret and compare the x-intercepts of both graphs. So remember, the x-intercepts is where it crosses the x-axis. So they both cross at 0, meaning they're both starting at 0 time. What about that first graph compared to the second graph? Correct. So that's exactly what we're going to say. Comparing that left one to the right one, the left graph shows that the uncontrolled transmission, the population got over that quicker. Versus the controlled population where they eventually got over it, but it took them a lot longer. Almost double just looking at the graph. So we would say the left got rid of their cases in a shorter period of time versus the right. Okay. And then the last part of this question is asking us to, it says, which of your previous answers tells you about the domain and which one tells us about the range? So which of these answers that we've already completed tells us about the domain?
We just did it. It's about the domain.
Good, the one that we just did. So the domain was the x-intercept problem. And we could say that the domain from start to finish was talking about what?
Time.
The time. And then the range was what problem?
The one before that.
The one before that, the vertex one?
Or I mean, it could be either, right?
It would be the y-intercept problem. Because remember, we're talking about the y's. And we could say that this range is talking about what?
Cases.
The number of cases. So this was the time. This is the number of cases. Okay, because it doesn't give us any numbers here for us to actually write a domain and range. This is just all something for us to use the graph to interpret. Okay, so now let's look at number 5. Number 5 says after t seconds, a ball is tossed in the air. The ball reaches a height h feet given by the function h of t is equal to 23 plus 144t minus 16t squared. So in this case, it tells us to complete the following table. So we're not doing the quadratic function now. Instead, we're going to do what to each of these t values? Plug them in. So the first one is 0. So we have 23 plus 144 times 0 minus 16 times 0 squared. What is that going to give us? 23. Okay. Then we're going to plug in 3. So 23 plus 144 times 3 minus 16 times 3 squared. Go ahead and do the math there and tell me, what do we get when we plug in 3? Remember, you're plugging that whole thing into your calculator. What do we get? Should have got 311. Okay, now I'm plugging in 6. So 23 plus 144 times 6 minus 16 times 6 squared. Remember, we're plugging this whole thing into our calculator, exactly how it looks. Okay, so you should have got 375. Now plugging in 9. Again, plug that whole thing into your calculator and you should have got 23. And then lastly, plugging in 10. And when we plug in 10, you should have got a negative 137. Okay, so again, all we're doing in this problem, since we had to complete the table, was plug in all those x values to get our y values. Okay. Now that we completed that table, the first question here says, from what height was the ball thrown? 23 feet. How can we tell?
At that time, it was 0.
Good, because the time is 0. The height was already at 23 feet, meaning the ball was thrown from a height of 23 feet. Say 23 feet. Because again, if we were to draw our diagram, we would see at 0, the ball was thrown right here at 23 feet. Okay. Okay, what is the height of the ball at 3 seconds? Look back at our table. 311 feet. Does the table of values show you the maximum height?
Yes.
Okay, we could say maybe, right? Because we're not too sure. We didn't plug in all the numbers, so we could say maybe. And if it did show us the maximum height, what could we take a guess at what it was? 375. So we could say maybe it's 375 feet. Okay, but we can't be sure because we didn't plug in every single number. But don't worry, in the next problem it says, what is the maximum height of the ball? So that means we have to use what formula? the vertex formula. So that negative b over 2a, and then plug that answer back into the function. So here, let's see, did it give us the function? Yes, it gave us the function at the top. So we're going to be using that function 23 plus 144t minus 16t squared. This is a little tricky because this is not in standard form. So what is our a value? Negative 16. And what's our b value? And we don't need to label our c value. Why? We don't need it for the formula.
So whatever has the square is always going to be your A?
Always.
Okay.
Yeah. So plugging it into our formula, we have negative b, so negative 144 over 2a, so 2 times negative 16. If you plug that into your calculator, you should get 4.5. Notice on our table, we did not have a 4.5. Oh no. Here, we didn't have a 4.5. It went from 3 to 6. So that tells us right away, is 375 feet going to be our maximum?
No.
No, because we said our maximum was at 4.5 seconds. So we're going to plug that 4.5 back into our function. So 23 plus 144 times 4.5 minus 16 times 4.5 squared. When we plug that into our calculator, we're going to get 347. So that means our maximum height is 347 feet. Okay. Then it says, using the table of values to estimate how many seconds it will take for the ball to hit the ground.
But the max, it says 375 right there.
What do you mean?
What do you mean?
At 375, it was still going up. There's no way that that's a down number, because then it would be lower than 347.
That's
At
correct. That's correct. Well then. You guys are the first class to point that out to me. I've been using these notes for like 3 years now.
There's a kid out there.
They just accepted it. Like,
Well, you guys are also the only class that's ever questioned everything I've done, so. I come in here like, do I know what I'm talking about? Okay. That's true. So, okay, so then we use that information. Well, no, which one would be the most accurate, though? It would be the vertex formula. We use the formula. So, let's just pretend this number is bigger than 375.
Or 347.
But you guys are right. Use that logic on the test. Use that logic. You know, like on the test, I'm not going to say use the table of information. I'm going to say use the formula.
okay.
Always use the formula. Now I'm going to spend the rest of today looking at this problem. Okay, using the table values to estimate how many seconds it will take the ball to hit the ground. So looking back at our table, at how many seconds do you think it will hit the ground?
About 9.5.
Good, we could say about 9.5 seconds, because at 9 seconds, it's going to hit the height of where it was thrown at 23 feet. So we could say at about 9.5 seconds, to hit the ground. Okay, let's see. Okay, let's go ahead and look at number 6. And number 6 will just be the last one we do. And then I will do 7, 8, and 9 in a separate video that you guys can watch later. Okay, so number 6. Says a ball is thrown into the air. The height of the ball above the ground is represented by the function negative 4.9 t squared plus 2.45 t plus 2, where height is meters and t is seconds. So it says, from what height is the ball thrown? How do we find that answer? From what height is the ball thrown?
Should we graph it?
So we can't quite graph it because we don't know. Okay, we could graph it, but then that's us creating a table. And we saw how that happened. The table wasn't
Yeah. We can't
accurate.
Can we plug in 0?
Good. We could plug in 0. What are we plugging in 0 for? H or T?
For T.
T, because T represents
0 seconds.
0 seconds. And at 0 seconds is where we find the height of the ball. So we would plug in T. So negative 4.9 t squared plus 2.45 t plus 2. Plugging in 0. The first two terms cancel, and we are left with 2. And we would say this is 2 what? Meters. It changed it on you. 2 meters.
So if we have a like that forgiveness the same as when we were asked the base question of the y-intercept, we would just use the y-intercept.
Correct. Correct. So, yes, you could just look at the equation and say, okay, the height from when the ball is thrown is always that c value. The c value in this problem is 2. Okay. Then it says, what is the maximum height of the ball? So what do we do to find the maximum height?
Vertex.
Negative b over 2a.
Correct, that vertex. Okay, so we have negative b, so it's going to be negative 2.45 over 2a, so 2 times negative 4.9. If we plug that into our calculator, you should have got 0.25. And then if we plug that 0.25 into our function, we should get 2.31. So this tells us that the maximum height is at how many meters?
2.31.
Yes. Okay, last part of the question here. So, how long is the ball at or above 3 meters? What are we going to have to do with that 3? Equals 3. We would have to set the function equal to 3. So 3 is equal to negative 4.9 t squared plus 2.45 t plus 2. But we can't solve this type of problem unless it's equal to what? 0. So what are we doing with that 3? So we have 0 is equal to negative 4.9 t squared plus 2.45 t, and 2 minus 3 gives us negative 1. So now that we have our function equal to 0, we use what formula? Quadratic formula. So plugging everything in, we get t is equal to negative b, so negative 2.45, plus or minus b squared, so 2.45 squared, minus 4 times a, negative 4.9, times c, negative 1, all divided by 2 times negative 4.9, which was a. So just plug in what's under the parentheses. or sorry, under the square root. Just plug that part in. Don't plug the square root in. When you plug that in, you're going to get what type of number? Positive or negative?
Because when you can't solve with 3, it has to be 0. So you move that over. So 2
Okay.
minus 3 is negative 1.
So if you plug in everything under that square root, you're going to get a negative number. Can we take the square root of a negative number?
No.
No. So what does that tell us about the ball?
Never reached 3 meters.
It never reaches 3 meters. Because remember, what was our max height?
2.24 meters.
Which is less than 3 meters. So we would say that the ball never reaches 3 meters.
I'm glad I stayed quiet because I was about to call it out and be like, hey, that's wrong too.
Okay.